Cool. They changed this. I can actually control my own recording now. All right. Give a couple minutes for the person to come back. We've got low critical mass here. And while I have slides that do not follow your rule of 27 point font.
It's 24 point actually.
Or 24 points.
I'm guessing you're not following that either.
No, I think I'm 17 because I've put a lot of verbiage on the slides for this one. It's not going to take the whole hour and a half, so we've got some time.
So that's the System 76 laptop you were telling us about?
Mm-hmm. Yeah, I'm pretty happy with it. It's,
cool.
You know, it's Linux, so it's got a couple of quirks in it, but I dual boot it to Windows if I really need Windows. And it generally performs really, really well. It's the first time I've had well, this is my first true Linux machine, right, where I wasn't running it in like a VM or something else. Definitely makes a performance improvement.
Yeah, I've been dual booting on my desktop for about 10 years now.
Okay.
And I had a full-on Linux machine at work as my main machine.
Oh, nice. Yeah, I just switched. It's over holiday season. I switched my desktop so I can dual boot it as well. Yeah, it's much better.
Yeah, one of my old desktops has Windows 10 and is not Windows 11 capable. So I'm thinking a few more days and I'll just boot it over to Linux and leave it there.
Yep. Yeah, I know a few people that are doing that. Okay, for folks just joining, we're waiting for one more person to come back and then we'll dive in. We're not really pressed for time here, so. Although it does kind of look like, do I look blurry on the camera? Blurry to me.
Not to me, but it's hard to tell.
Just slightly, but it's not bad.
Okay. There's not anything I can do about it anyway. It's the, you know, camera of the room, so. Folks, a little more time to get here, and then we'll dive in. I see sneakers walking this way. Maybe not. Oh, there they are. Okay. We'll get going here. Welcome everyone to the March Northwest C++ user group meeting. We'd like to thank Microsoft for sponsoring our reactor room and our team support. As we are on Microsoft's campus and such, please remember we do have a code of conduct. It's Microsoft's code of conduct. Pretty simple, just, you know, be respectful and nice to everyone. Announcements. So in July, we're going to do something a little different. We're going to partner up with the Rust user group, who is meeting just across the way. And we're going to do a language panel. The talk tonight is actually a little bit of a philosophical intro, but we're looking for panelists. Basically, we're going to have a whole set of languages. You don't need to be an expert in any of these languages. As you'll note, like Carbon, Mojo, Hilo, and Circle are, you know, somewhat experimental. But if you would like to represent one of these languages, and we'll have other languages as well. These are just the ones we're looking for.
No. C#, Mojo, and Hilo are covered. I'm doing those.
You are?
Yeah. We talked over email. I'm Ted.
Oh, hi, Ted.
Pleased to meet you. Yeah.
Just let you know.
Yeah. Oh, thanks.
Yeah. I mean, I know we're doing Mojo, or I know I'm doing C#. Mojo and Hilo I was going to fill in if you couldn't find anybody. So
okay, so I've got a typo in my slide.
Yeah.
Excellent.
Awesome.
Thank you.
Okay, so we've got that. And do you really want to do 4 of them?
C#, Mojo, Hilo.
C#, Mojo, Hilo.
That's 3.
Oh, that's 3. Okay.
And yeah, I could do 3. I mean,
okay.
I could do Go. I just don't want to because I don't like it.
Okay.
So, but, you know.
Well, that's good feedback too.
I'm going to put a quick little note to myself in here then. What the?
We did more than you planned.
Control Z, Control Z, Control Z, Control Z. There you go. Yeah, I've been, I was teaching C# for Developmentor back in 2001. And Mojo and Hilo, I would be coming to.
Okay.
I did an article for Code Magazine on Go like 5 years ago, so it's been a while. So you've got
We got
three
him.
of those 6 covered.
We've got enough.
What have you done today?
He's doing Swift.
Yeah, I'm doing Swift,
Okay.
but I've only got one covered. So I'm not living up to your standards.
And I think I'm doing C++. So we've got enough panelists. So, and we've got a person doing CPP2 as well.
Excellent.
And a person doing Rust. Brad's going to do Rust. So
Boo. Sorry, didn't say that enough.
we've got it all covered. Anyway, so folks, for the July meeting, and I just set this up with Anna, we'll be meeting, if you're here physically, we'll be meeting in the bigger area. And folks online, it'll be just the same. I'll just give you a link. The August meeting is going to be lightning rounds. So if you would like to do a short presentation, just show up in August with a short presentation. If not, we'll find something, to discuss. If you want to do something more than a lightning round, September and on is still open. Excuse me. After this meeting, we will all meet at we don't have to, but some of us will meet at the NWCPP Coffee Club, which is at the Red Robin on 148th and 24th. Everyone's welcome to join. Just a note, I will not be able to make it tonight because I've got an early meeting tomorrow. So, and for our feature presentation, just please keep the questions short and focused so everyone gets time, and don't interrupt the speaker or other members when speaking. So with that, I'll turn it over to our featured speaker for tonight, which, happens to be me. Okay. So the talk tonight is choosing the right language for your project. The introduction, this is basically, what I want to do with this talk is look at programming languages as a set of properties and features, and which is not typically how folks tend to think of programming languages. We'll talk a little bit more about that as we get into it. The goal of this talk is to really get you, though, to think of a language, or all languages essentially, as a set of features and properties, and then match those features and properties to the problem you're trying to solve. A bit of background. This talk actually came from a comparative languages class that I took in college, where we did fundamentally just this on a much more deep level. Languages were simpler at the time, too. And I found this to be very, very helpful in my career. And at the same time, I find very little mention of this or this way of viewing languages ever being discussed or taught. Just quick, has anybody run into a comparative languages class in college or aware of one that's current?
I took one, but it was a long time ago.
Yeah, it's the same here. This, dating myself slightly, 30 plus years ago type of thing. But when starting a project, a couple of times we've actually gotten to look at, saying, hey, what language do we really want to use? And when we haven't gotten to do that, or when I haven't gotten to do that, it's here, use this language. And not every time, obviously, but on a reasonable number of projects, the language choice was a very poor match for what we were trying to do, and it caused significant problems during the project. So that's kind of what this talk is about. As for the set of language properties that we're going to talk about, here's a list of them. I've got a slide or so for each one, so I won't go through them all. This is by no means exhaustive. Um, there may, one of the things not listed here is, hey, I just want to learn this one, right? Or, yeah, that's the silliest one I can come up with for properties that, your own project, fine, but major corporation, just because you want to learn the language, probably not a good one. So we haven't talked about that. But anyway, there's a whole bunch of these that, could be added to this list. Okay. So the first one is general versus domain specific. So there's generally two groups of languages, right? At the top level. You've got a general purpose language and, C, C++, C Sharp, Rust, Python. I guess you could even say something as, like Lisp is, somewhat general purpose, right? And then you've got some that are very, very specific. For instance, SQL. The only thing you really do with SQL is database access. HTML, CSS for web pages, VHDL, Verilog. CMake, it's really only used for build systems. Although I did make a joke with my boss at one point that, we could write our test program in CMake. Technically, you could. It's Turing complete. Don't know why you'd want to. And then, there's also languages like QML for forms design. When you're in a case where there's a domain-specific language that's a natural fit, you just kind of use it, right? We really don't have to think about that. But one question to ask is, for the project that you're building, is there value in creating a domain-specific language? And sometimes there is. I've had two particular cases that I've come across where it was necessary to create a fairly simple domain-specific language. And the common theme for both of those was I needed a non-programmer or a non-software engineer to be able to read the thing, right? And so in both cases, it just provided a really simple interface that somebody else could read. But it's a good question to ask. Next step down is the language class or genus. Genus I'm kind of borrowing from biology. And the fundamental way a language is formed has a huge impact on what types of problems are naturally solvable in that language. As I was just kind of joking with CMake, as long as the language is Turing complete, you can generally solve, any problem with any language, right? Assuming, APIs, you can make system calls or a few boundaries like that. It doesn't mean it's going to be natural, doesn't mean it's going to be efficient, or it doesn't mean it's going to be maintainable. The one that really gets you, at least from what I've come across, is, what knowledge is known at compile time, and what do you have to figure out at runtime, right? That makes a good first cut. Do you need a language that's somehow interpreted or JITted at runtime, or do you know if enough at compile time you can use a compiled language, right? So that's a good first cut at these. And then after that, it breaks down into a whole bunch of, families, right? Classes or genuses. Procedural, Fortran, and C are, examples of that. They're just straight procedural languages. Object-oriented, C, C++, and C Sharp. They're kind of poster child calling card in my mind is if you have to model complex objects, you might want an object-oriented language because it has direct support for that. Declarative, SQL, QML. Key there is you specify what you want done, not how you want to do it. Functional is things like Haskell and Lisp, and they carry advantages for reliability, and scientific apps tend to fit into that nicely, or when you're working with a lot of formulas. Yeah.
Is Lisp really functional? To me, it seems more closer to procedural or object-oriented.
Thus, did you just step into one of the great debates of all time?
Yeah. I included Lisp because when I actually learned Lisp decades ago, it was presented as a functional language.
Okay. It was presented as a procedural language. Any kind of beast.
Yep. Yeah, and actually the comparative languages class that I took used Lisp as its poster child for a functional language. So yeah, it's, again, some of these are not cut and dry. One will notice I did not list Rust anywhere on this list, right? Because it has aspects of functional, it has aspects of procedural, and it has some aspects of object-oriented, right? So especially with modern languages, because we're trying to get a one shoe fits all, you're seeing them, these lines are blurring to a certain degree. And sometimes that's a benefit and sometimes it's not. And there's others that, don't get as much, traction or publicity. Ladder logic type languages, reactive languages, aspect-oriented, data flow. Poster child for data flow is LabVIEW. It's a graphical language. Basically, if the class of the problem you're trying to solve naturally fits into one of these groups, use that group, right? Use the right tool for the job. Okay, next big cut is translation method. And we talked about this a little bit before. Essentially, this is the compiled versus interpreted versus JIT discussion, right? What must be expressed during development time versus runtime? You want to look at the runtime performance. You're essentially trading work for compile time versus runtime is the classic trade-off here. If you have real-time limitations, you're almost certainly going to want a compiled language. Depending on what real-time means for you, that's a somewhat fluffy topic all by itself. Startup performance, sometimes that matters, sometimes it doesn't, right? If you're running on a server, hey, your app may start once and run until the server goes down. And if anybody started up a server class machine, those things take 5 minutes to boot on themselves. So the execution and executable environment size, it's another one. And essentially, the compiled versus interpreted, you're trading work done during development for work done at runtime. You're trading knowledge specified during development with flexibility at runtime. You're trading determinism for flexibility at runtime. And you're shifting your environment complexity from development to runtime, right? It's just basically somewhere you've got to do the work. And where do you want to do it? And where can you do it? JIT I've messed with a little bit in various forms, and not just in Java, for instance, in Python. But it provides the best of both worlds and the worst of both worlds, right? Sometimes it's a good fit, sometimes it's not. Yeah. Okay, next dimension is memory safety and memory management. This is kind of the hot topic at the moment, given that the the government discussions around using memory safe languages and so forth. So this one's really been brought to the forefront lately. Essentially, every language has a model of how its memory is handled, and the language is very much built around that model, right? They all are typically flat these days. I don't think I've seen anything in main production that doesn't use a flat memory model. But there are research languages that use transactional memory. In the past, there's been banked and paged memory. Those have kind of gone away. The bottom tier of this is manual memory management. So you're doing everything yourself. It's the most flexible. Sometimes it's required, right? Especially if you're doing low-level hardware access, for instance, on a microcontroller. Your DMA buffer, you're going to have to allocate and manage that yourself at some level. You might get a library to do it for you, but somebody's got to manage that directly. It's also the most error-prone and the least safe. Okay. Next step, it's also the best performing, right? Because you can do exactly what you need to do only what you need to do and when you need to do it, right? But that comes with, if you don't do it right or you forget about it, it don't get done. The next one up is reference counting. And that's actually pretty common these days as well. It can be used almost anywhere memory. Oops, I got a typo and I'll have to fix. Anywhere manual memory management can be used, except maybe some direct hardware allocations. It's very good safety if it's actually used, and it's good performance, but the determinism can vary depending on the implementation. Sometimes when your reference count goes to 0, your deallocation will happen immediately. Sometimes it's queued for deallocation later. Depends on the implementation. The big thing I've run into with reference counting is with a couple of exceptions, Rust being one in particular, it's always opt-in, or it's usually opt-in, I should say. And it tends to go along with manual memory management, right? So it's great when you use it, but you got to use it. Garbage collection, it's the worst flexibility because everything's managed for you. It also tends to be the worst performing, but it's the best safety because everything's managed for you. That does not mean it's completely safe. I've seen people do things that create memory leaks with garbage collectors, namely circular references. You build a circular reference and then you detach from it, and some garbage collectors will pick that up and some won't. One thing I will say about garbage collection, because I've run into this many, many, many times, if you're doing something that has a real-time or deterministic aspect to it, please don't use garbage collection. I've heard many, many arguments for, yes, we really can, and then it goes south really, really bad. Okay, thread safety and management. This one's a little fluffier. Languages vary greatly on support for threads and exactly how those threads are implemented. Some languages have thread implementations directly in them, in some fashion. Sometimes they call them threads, sometimes they call them fibers or a few other things, but I'm kind of lumping all those together. Go being one of those languages. And some of them pass to the OS, and some of them I'm not even sure if Lisp you can do a thread in it.
Not out of the core language.
Yeah.
A lot of the more commercial packages of Lisp went ahead and added, like if you go to Racket, they've got a package that would let you do threads, but it's not a part of the core language.
So the first question though is that I always want to ask is, does your project need to be threaded at all? Right? Do you even need to consider this? Many times I see threads, especially these days, used where they really don't need to be. The other question there is, maybe you can or want to use an async programming approach, right? And again, now you're just, kind of pushing the whole thread question away. Don't need to do it. It can just be handled by itself. If you do need threads, how extensive do they need to be? Again, I've come from a industrial automation, high reliability background. And the minute you put a thread into something, your life gets a lot more complicated really quickly. So we would go to a fair extreme of not using them at all. That changes over time. You will note that a couple months ago, I did a CUDA talk, which is a lot of threads, right? Pick the right tool for the job. And if you're going to use threads, what is the communication pattern between the threads? Right. So you want to get all this worked out in advance and make sure it matches the technology and in some cases the libraries that you're using. The main guidance here is to design your threading and communication architecture before you choose your implementation. Right? Am I going to have no threading? Then I don't even need to think about this. Am I going to have something that's massively parallel because it needs to be? Okay, then we'd really put some design into that and make sure the language and libraries support it. Okay, industry standards and norms. This is a little bit of a softer one. Some industries just have de facto standards. They change over time. They generally do not keep up with advances in language development. Um, a couple of these, just examples, scientific computing tends to, even to this day, still use a fair amount of Fortran. C and C++ are also pretty well represented now. In aerospace, ADA for many decades was just the de facto standard, and I think there was even some requirements that stated you had to use it in certain areas. That seems to have faded. C is, C pretty prevalent now in aerospace. C++ is also there. Finance, C and C++, just for high-speed trading. Automotive, C pretty much rules, specifically because of MISRA C. It's a formal standard that says, hey, if you're writing something that's, controlling the throttle or any critical aspect of the car, it needs to be MISRA C compliant. There is a MISRA C++ standard in works. I haven't run across it lately. I don't know what the status of that is. I do know it's floating around. I don't know if it's been completed or accepted or kind of where that stands. Testing world, they just tend to do things in Python. Just a quick note on the testing side. Again, because this was a scenario I actually got into with a testing system that had real-time constraints. Python was just kind of dictated because it was before I got there. Again, using Python, which is garbage collected and interpreted with a real-time system, led to problems. We overcame them, but it led to problems. Basically, we dropped to C and did that part there and back up to Python. Yeah. So, sometimes these choices are just made for you. Sometimes they're just a de facto standard that, hey, we've always done it this way, and well, we know how to solve the problems. Sometimes it's, hey, we've always done it this way, and we don't know what the problems are. Okay, next one is company familiarity. Just like you have industries that kind of have de facto standards, companies and departments typically have their own de facto standards. At least what I find most of the time with industry standards is because there's a lot of people involved, they tend to settle into something that's at least reasonably usable. Company and department standards tend to be much more ad hoc. Somebody just made the decision and it may have worked for them at the time, and they're going to start a new project. And well, we've got a team of C++ programmers, so of course we're going to use C++. Sometimes that's okay. Sometimes that will bite you. But things you should be thinking about from a company level or from a departmental level. What type of staff do you have? Do you need to train or rehire? And make that trade-off between, learning or rehiring and the impact that's going to have on the project, right? That's a trade-off you should make consciously. And it's going to be a balancing act. Do you have company-specific libraries that you need to support? Do you have company-specific tooling that you're going to need to use? Because a lot of times the tooling is specific to a language, or in particular, because I run into this even more often, an operating system, right? Our CI system runs Linux. And, well, some languages you just can't drop in there, right? Same thing for Windows. Some companies actually do have specific policies. I see this around Python most often, where a company will say, this is essentially the supply chain poisoning type of aspect, where you're pulling in libraries or packages from outside, which Python tends to do pretty extensively. If you're in a high reliability or regulated area, they just say no, right? Or if you're going to do that, you need to maintain your own repository, be meticulous about the packages you pull in, and basically vet those so you know what's going into the product. So that type of a policy may very well dictate which languages you can or cannot use. Uh, Next one's ease of getting through formal or external reviews. Security reviews, I would put into that. Sometimes a language, just because it's the de facto standard of the industry, the reviewers know it, they're happy with it. It may or may not necessarily be the right thing, but if you change it, they're going to give you additional scrutiny, and you should be able to justify why you changed it. And then finally, the forward looking, which way does the company want to be moving, right? Do they want to be moving away from, unsafe memory languages or moving towards some particular language for some reason? Yes.
So one of the things you talked about is measuring the cost of training or rehiring staff.
Mm-hmm.
How do you measure that? So let's say we've got a company of people that have been using C++ for a long time.
Mm-hmm.
Suddenly we decide we want to use Rust. How do I figure out how much that's going to cost me?
Yeah. So I've done exactly that same thing where I've had a group of C++ developers, and then we decided to use Rust. The way I approached it is, and this was a little bit of a longer term thing. We had kind of a core Rust group, and then we had more C++ type stuff that we were kind of moving through a transition. What I did was just estimated, first off, from my own experience when I learned, folks know me, I've been a C++ guy and still do some of it, but my background's primarily C and C++. How long did it take me to learn to become proficient when I started doing Rust, right? How long did it take me to go through that experience? And it was a couple of months-ish type of thing, and depending on, it was a couple of weeks until, I got proficient to where I could kind of do things on my own. Without, help from somebody who was kind of coaching me and mentoring me a bit. And then I'd say it was about 3 months before I really got proficient with it, right? And I wouldn't call it, that's not an expert. That's just proficient to where I could make good cadence. So that was my first estimate. How long did it take me to go through whatever transition, it was? In this case, it was C++ to Rust. And then we picked up a person, Rust developers, and they're getting better, but they're pretty hard to find still. And then I took them through that transition, right? So instead of me being the mentee, I was the mentor now. And I found, it took them about the same amount of time. And then we did it with another person. And it took them about the same amount of time. Now I've got a baseline, right? A typical programmer for this particular conversion from C++ to Rust took about 3 months to go from, I've never touched this language before, to I'm reasonably productive with it, day to day, right? And then you could just multiply that out and say, okay, we need to transition this many people. I would also say if you're going to do this as with an existing team, because it just occurred to me, this actually much earlier in my career, when I learned C, we went from basic, right? Much, much earlier in my career, to C, right? The company that we were working with, started doing all their stuff in basic because, well, that's what you had at the point. And we went to C because, well, the computers got fast enough you could actually do it. And the entire group of us went through it together. If you're going to do that with an entire group, I would actually say the learning time actually goes down a little bit for the entire group. The reason being you've got an entire group of people who are all going through the same experience and they can answer each other's questions. And it was long enough ago, I don't remember what the time was. But, again, you could, see what other groups have done to do something similar. Okay. I don't know if somebody's coming in or not. Other questions on training? Oh, Dan. Hi, Dan. Did you have a question or is that just a hand wave? I caught it out of the corner of my eye and you're on mute. Okay.
I think the flicker you saw was him joining.
Oh, it could have been. Yeah, I literally caught it like right at the edge of my vision. So,
Yeah, I was just waving hi.
oh, okay. Okay, next one is community support. So this is basically an extension of company support or vice versa, right? It's the same basic question, just a difference of scope or scale, right? How easy is it to hire developers? How's the language libraries? How's the tooling? How expensive is the tooling? What's the regulatory environment? Ease of getting through and now you're going to say external reviews. In this case, I'm going to call out the FAA because sometimes in certain cases, the FAA wants to see your code. And, they're used to looking at certain types of code for certain types of applications. If I write my flight termination system in Lisp, that's probably going to give them a real, right? And, what direction is the industry moving? One of the things I'm going to point out here, and this kind of falls into all of them, specifically for C++ and kind of would go for Python up until about a year or two ago. When you're picking a language that has a long history and multiple versions, you should also be asking this question around specific versions, right? In the case of Python, Python 2, Python 3, there was multiple years where that was kind of in transition, right? And sometimes Python 2 would be the right answer, sometimes Python 3. Python 2 is now gone, so it's probably no longer the right answer to start a new project with. Take C++, for instance, where we've got legacy C++, modern C++, which whatever that means to a certain person, I usually take it to C++ 11 and later. Although some people take that as up through like C++ 20. And maybe bleeding edge C++, which is C++, 23 or even aspects of 26, right? You should be picking the version that you want as well in that case, right? And it's all the same questions. Let's see. Oh, there was one more aspect with community support that I wanted to point out. Depending on the business model that your company is in, right? This question can actually be turned on its head, right? The key is, in most cases, you kind of want community support, right? It's like, hey, I want to be able to hire developers and I want to be able to go out and get libraries and so forth. For some businesses, if you're in that library building or language providing business, not having libraries or broad community support, or if you're training, not having, knowing that they can't find people for things, that's actually a motivation to pick the language, right? It's a business opportunity where you've identified a problem and you can go in and solve it. And granted, that's a narrow slice of businesses, but recognize, depending on what you're doing, this could flip both ways. Okay, use in regulated environments. Typically, a regulated environment is medical, aerospace, automotive, and finance, this is where you have some type of regulatory agency that's going to come in and review and or approve your project. There's actually a couple others that you get into. One, it's not directly regulated, but children toys that are internet connected for children. There's regulations, and you have to go through a little bit of scrutiny to make sure you're not collecting PII or sending the child things that are inappropriate through the internet, and some things.
The big one you missed from that list, by the way.
Oh, go ahead.
Government.
Yes.
Government. Anything the government uses.
Yep.
Generally, like for example, when I worked at Smartsheet, government wanted to use it, and so we had to figure out how to move to FedRAMP.
Oh, okay.
It was a non-starter.
Good point. Thank you. Yep. So one aspect, 'cause I've done a fair amount of aerospace. One of the things that you run into there, anything that's for flight, right? Anything that's going to go on the vehicle is much more heavily scrutinized than, say, tooling and support and so forth. One aspect that comes into that is the language that is used must have a formal specification. This ties right into how it's qualified. That knocks some languages out of the running, right out of the start. Namely, when we actually did this exercise for Rust several years ago for a project, and that popped up, and it's like, nope, can't use Rust. Right? It didn't matter anything else. It did not have and it still formally doesn't for Rust itself, but can't go there. Right now, there is Ferrocene and a couple other sub projects that pick that up and address that niche. Right. So again, to my last slide, if you're one of those businesses, you can build a business on these gaps. And there's, I can't remember who makes Ferrocene. I can't remember the Ferris Systems. They built a whole business around this because there's no formal specification. People want to use it here. Hey, we'll build a business doing a formal specification. Okay. Let's see. Okay. Yes.
You've also got the case where you have the language spec and like what happens in this situation. Implementation dependent, or it's unspecified as to what's going to happen, which kind of defeats having the formal spec.
Yes, definitely. Next one is portability. How easy is it to port your code from one platform to another? Some places this matters, some places it doesn't. Most languages these days are pretty portable, so it's not as big of an issue as it used to be. But you need to consider various operating systems. The space I've worked in mostly is Windows and Linux, because they're kind of the big ones, everything moves back and forth pretty readily. Mac, basically kind of ties in with Linux, right? Things like Chrome OS, QNX, VxWorks, and some of the more Vigo. There's a whole bunch of other operating systems out there. Typically do not have support either for the less mainstream languages or some of the libraries. So if you're going to go to any of those things, you need to be aware of it. The other one you need to look at is processors, x86, ARM, RISC, PowerPC, MIPS. I had one project that we did about 7 years ago now. I'm just throwing this out as an example. It was a bit overdone and we corrected it, but it was on microcontrollers. We were working in C, and we had no idea necessarily which microcontroller we would jump to next. It was a pure research type project. The person in charge of that at the time specified C89. So keep in mind, 7 years ago, this would have been about 2014, 2015, somewhere in that range. And we were using C89, not 98, 89, right? Specifically because, we can get compilers for this for darn near anything we want. Okay. We did eventually kick that up to C89, or excuse me, C98, which was a lot better. Library dependencies can also limit your language choice. Just having FFI or foreign function interface in whichever form they call it is not necessarily always enough. If you're going to use a particular library, you want to make sure you can actually link to it. I had one case where we were forced into C++ because even though you can cross-link, the library that we needed to use in the form we needed to use it was only released for C++ with a certain compiler, which was GCC. So, don't just think about your library, or don't just think about your language. Think about the libraries and any other dependencies that you may run into. Okay, automated tooling. What automated tooling exists to support your language choice? Your build systems, your CI systems, packaging, linters, the whole tool chain, right? Essentially, the main comment I want to make here, most languages are text-based, right? Pretty much everything we've talked about, either in this group or most of the other groups here, they're text-based or devolve into some type of text-based thing, right? That's actually provides a pretty good common level of support. There are languages that do not share that common level of support, namely graphical programming languages. The poster child here is LabVIEW. Another one is Blockly. Those languages, you cannot use the bulk of tools with. You can put them into Git, for instance, but you cannot do diff merge, and that absolutely affects how you have to build, not only architect the project, but architect your teams and the size your teams can scale to, right? It affects the way you do code reviews. That type of thing permeates your entire workflow. So you need to make a choice of, especially, and I'm not ditzing LabVIEW per se, because LabVIEW is great for controlling complex instrumentation, right? But if you're going to go down that path, make sure you know what the trade-offs are. In that specific case, you're going to trade ease of code development for complex instrumentation for reduced support in your tooling and infrastructure. Right?
This has actually been a huge problem for the Smalltalk community for years.
Oh, really? Okay.
Smalltalk is still a textual language, but much of the Smalltalk experience has been wrapped up in the Smalltalk browser. And so, for example, one of the things the Smalltalk browser will do is it will store what changes you've made in its own format.
Yes.
Which is fundamentally a binary format, right? There's text obviously there, and so a lot of the Smalltalk community, in order to be able to take advantage of this stuff, has had to figure out how do we, and this is where actually GNU Smalltalk sort of came into play. It's like, we're going to do a completely text-based thing. And you want to talk about, really a redheaded stepchild.
Yeah.
Nobody, none of the GNU family really like GNU Smalltalk. None of the Smalltalkers like GNU Smalltalk. It's just kind of there, and nobody really wants to admit that it exists.
Yep. And you can get into this, like very much like you were just saying, under the hood as well. I ran into this, I guess it would have been decades ago now, with MFC, Microsoft Foundation classes, right? Initially, and I can't remember the version number, it was early versions, right? Like 2 or something like that. Early versions, the way Microsoft Foundation classes interacted with Visual Studio, a lot of the GUI work was hidden under the covers, right? You went into and it was great at the time, right? It was groundbreaking at the time. You just went in, you drew your windows, and you hooked it up to your code, and off you went, right? And then came the advent of revision control systems, and that magic that let all that work was, I don't know if it was exactly not text or raw binary, but it was not in a form you could diff merge in any way, shape, or form, right? And it took them a year or two, and then they fixed that. But we if you're working with something that's maybe not quite, it's newer, or there's several other examples of this, I'm sure. Try it.
Xcode storyboards.
Okay.
Right. The storyboard, when you create an iOS app, or generally iOS, you could do Mac OS too, but the storyboard, right, which is this lovely graphical thing where you can watch all, drag and drop all your controls and whatnot. All of that is stored in an XML format. And we say, okay, it's text. Except they rearrange everything. I teach iOS for the University of Washington to the undergrads, and every quarter, they run into, when they do a group project, one person has to be designated as the UI
Yep.
czar. They're the only one allowed to touch storyboard because you can't merge a storyboard. Even if you just moved a button 3 pixels to the left, the order of everything gets rewritten.
Yeah.
It's the most frustrating thing. And Apple has refused to fix it for going on at least a decade now.
It's
Yeah.
better in Swift.
I've not experienced it being better with Swift in that
I
respect.
haven't used storyboards for my development.
Oh, you're talking about Swift UI.
Yes.
Yeah.
Okay.
Unfortunately, a lot of the mobile dev out there is still done using storyboards. So I kind of want to teach the kids storyboards just
Yeah.
because. And I warned them and they never believed me. And then at the end of the quarter, what was the biggest problem? Yeah, merging storyboards. I warned you.
And you actually reminded me of the other one I was trying to remember and couldn't. It's not even necessarily the code directly. It's the project files. I've run into problems with this as well. Specifically, and I don't know, again, this was multiple years ago, again, about 7. But Unity, for instance, the individual files and the scripts and the code and, of course, you got large binary assets, which is a whole nother thing, but, but the project file was stored in some weird format that got tweaked every time. And if you did a diff merge, you had to rebuild the project file. So same type of thing. You come up with the czar, and everybody gives that portion to the czar, and they're the only one who can touch that file.
Yeah, doing game development, Unreal Engine is the same. They have a blueprint programming language where you draw lines and boxes.
Okay.
Totally not mergeable, but they do have a built-in diff tool for your own changes. You just can't diff against somebody else's changes.
Okay.
So you can't really merge. You can just see what you changed.
Yeah.
Yeah. And Microsoft, going back, you're talking about MFC, their old project system used to be binary.
Okay.
And 10, 15 years ago, they finally made the flip to convert it over to, I think when they made the solution project distinction is when they said, we're going to rewrite all of this to be text-based, which is the core of what they've got now with the .NET package project tool, the command line thing that they've got.
Yeah. So if you're going to get into that, be aware that your choices can fundamentally limit the size of your team, right? In the case of LabVIEW, it was a recent, the project I was working on, it was a reasonably small project, right? And, I decomposed the project because it naturally decomposed this way into 2 major blocks. I got 2 developers, and that was it. And in several points, the discussion came, well, okay, can we speed this up by adding more developers? No, right? Well, why? And you go through this whole rationale that we just did, right? So keep in mind that that's a consideration. Okay, execution environments. A lot of the times your execution environments are the same. However, this is not always the case. Embedded systems in particular, you want simulation and emulation support that speeds your development cycle. Typically, you can use this to start the coding effort in parallel with the hardware development effort, so you don't have to serialize them. But you have to plan for it, right? You have to choose languages and tools that support simulation or emulation. In testing environments, you basically want simulation or emulation to allow for fault injection, more detailed monitoring, and validation at various levels of testing. Again, it's something that, your tooling and your language choices have an impact on. Large-scale development, your test and development environments are going to be subset of the production environment, right? You're not going to get to, have 1,000 servers for your development environment. Although maybe if you're Google, you might get away with it. But for most of us, you're going to get, 10 servers for your development environment. And you have to understand how that's going to scale to the 1,000 server production environment or whatever those numbers happen to be. And again, I've seen various aspects with Kubernetes, virtual machines, simulated hardware, ganged hardware, where you have a library of hardware, and you want to be able to have hooks between your development world, your testing world, and these environmental control or environmental automation tooling. So this gets us to the next topic, which is multiple languages. This is something I found over the course of decades has changed considerably. When I started programming decades ago, we haven't figured this out by now, you typically picked one language and that was it. It has been well over a decade, maybe pushing 15 to 20 years since I've done any project that only used one language. And I'm counting tooling and so forth in all of this, right? A trivial project these days, I'm just kind of making this up out of my head. You're going to have something like C++ as a primary language. You're going to have something like CMake as your build system. And by the way, CMake falls into make, right? So you've actually got a hidden language in there that you may or may not have to deal with. And if you have a database in there, you're going to be typically talking SQL to it, right? About 3 is the smallest number of languages that I really find anymore. And 5 to 7, depending on exactly where you draw the line, is actually pretty common. So basically the technique you want to use is, put each language, in an area where it shines. Now you'll notice 2 of these I've listed are domain-specific languages, right? CMake and SQL, they're, very specific. So their role is pretty obvious. Sometimes it's not. But recognize that in modern projects, there's going to typically take multiple languages. That generally requires a larger and more diverse team. Overall, your trade-off is it allows the project to be completed faster. You're using the right tool for the right job, and you're getting an efficiency gain from that. And you want that efficiency gain to be more than the cost of the additional person you need to be bringing in for it. And then, of course, you're going to get into language interop. If you really get into this, that's another talk. Okay, in summary, this is, we're going to finish a little early. Choosing a programming language for a project isn't a given. It's typically is not given enough thought or time. It just kind of generally happens with groups. What I'm trying to get folks to do here is to ask the leading questions. What do I really need? If you don't do that, you're going to end up with increased development times or incompatibilities. It's going to make your project more troublesome, less maintainable, possibly even less efficient at runtime. What I've found is really useful is to take a spreadsheet, and I've got an example of one below, and just simply list out, here are the properties or the aspects of a language that are important to me. List those across the top. Then you can list the languages you're considering down the side and just fill it in. This may be everything from as simple to, check boxes, right? To putting some weights on these things, depending on exactly what matters. I've actually had one project in my entire career. Back to my point, this isn't given enough consideration. There was actually one project where we took the time to go through the project. We had a layout of what we wanted to do. We identified what the critical properties were. And then we actually did small prototypes in a couple of the different languages, specifically C, C++, Rust, and Go. We'd already knocked Python out because we'd made the mistake. And work through a table like this. If you've never done it, it's actually worth doing as just a exercise in and of yourself to pick one. Just that awareness and having gone through the exercise will give you good insight into, which way to go for a particular project if you're not given enough time to actually do a proper analysis. That's all I've got. Questions, comments, discussion.
Comment, one thing I didn't see you mention is some operating systems have a language they want things to be in. Now, this is not Windows, for instance, but for Android and for iOS, Android really wants things to be in either Java or Kotlin.
Yep.
And iOS really wants things to be either an Objective-C or Swift.
Yeah, good point.
Now, you can still, if you have a really, really big project, you can just write the part that interfaces the operating system in your Java, Kotlin, Objective-C, or Swift, and write the rest in C++ as a huge library that they call into, and use multiple languages. But if it's something small, you might just want to base it on the native language of the platform instead of going through a more complicated decision tree.
Yep, it's a good point. Other thoughts?
Well, I was going to, we can debate this later if you'd like.
We got a little time.
Well, the whole memory management thing, the garbage collected versus manually managed. When I was doing C# classes, I would frequently be brought in to teach a bunch of old school crufty C++ developers. And one of the things they would all get very, very upset about is the whole notion that they were no longer able to explicitly manage their pointers.
Oh, yeah.
And aside from the fact that usually those are a class of bugs, and I don't care how good you are, even Scott Myers could never come up with the perfect smart pointer, and he admitted as much. But garbage collection is actually often faster than doing manual memory management. Nobody believed me when I did this.
Yeah.
So we would run a shootout. I would write some C# code, and I would write the equivalent C++ code, where essentially create a very simple person object, and then we'd go in a tight loop and we'll allocate 10,000 of these.
Mm-hmm.
And it's not actually until you get to stack allocation that C++ was able to beat C# in terms of just raw processing time. Because a garbage collector can do a number of things that generally manual memory management cannot, which is to say I can defer a lot of things.
Right.
So you have to be kind of careful when you say manual, faster, garbage collected slower.
Yeah, that's a good point.
This was true back in the old days, particularly if you do simple mark sweep algorithms, particularly as your heap gets larger, going through that pass through a 2 gigabyte heap. Java ran into this problem. But they very quickly figured out some GC algorithms, and frequently they use some hybrid models to make sure that new object allocation is extremely fast, usually using a copying collector. And if an object survives a certain number of passes, it gets pushed off into a second generation, sometimes even a third generation, which we don't check anywhere near as often. You can often get much better throughput for most programs.
Yeah.
Using a GC-based approach. The other danger with reference counting is circular references.
Yes.
Right. And that's the main reason. That was the thing that Apple ran into in the early days with Obj-C and Swift when they said, we're not going to do garbage collection on iOS. Well, they had to introduce ARC, which originally was an explicit thing in Obj-C 2.0, automatic reference counting. And then later they kind of buried it underneath Swift, but you still run into this problem. And occasionally people have to be told, oh, well, if you've got two persons and they each have a spouse field pointing to the other, just because you've dropped your reference to them in your code doesn't mean they actually go away, which means your iOS program slowly goes like this until it dies.
Yep.
So it's a very muddled subject.
Yeah, no, it's a hot topic. The one I've run into with garbage collection, now keep in mind, I do a lot of real-time work, right? And when C# first came out, I was like, cool.
Yeah.
Right? Because there was a whole bunch of stuff that went away. I was doing MFC at the time, and the .NET libraries are actually very much, in some ways, more robust than the MFC libraries, right? I was in that space. And when C# came out, I was like, oh, cool, I could do all this on steroids, right? And I never got as far as measuring the performance of the garbage collection. What killed me was when the garbage collection occurred.
Yes.
Because everything would stop. And if you're controlling a machine and your control program stops and your machine keeps moving, that's something you can never have happen.
Yeah. And some of the early.
So that's another dimension of that problem, which they, in some cases, they have addressed.
Yeah.
I know there's now ways that you can control that. We actually came back and looked at it with Go, right, in this last, and it turns out, because Go, I'm not an expert exactly on this, but Go tries to analyze the execution pattern of your program and sneak the garbage collection into the idle times, right? It's got some, and we found that even wasn't good enough for us.
Yeah. There's a really good book. It's actually been a series of books. It's the Garbage Collection Handbook by Jones and Limbs that walks through the whole family of different kinds of collectors.
Yeah.
Because on the one hand, there's how do we do the allocation and reclamation, the path, the algorithm we use, mark sweep, and so forth. Mark sweep compact to avoid heap fragmentation, which is something that a lot of native languages do run into. The other thing is, when exactly do you do it and how exactly do you do it? Because when you see those pauses, that's typically what they call kind of a stop the world collector.
Yep.
In other words, because, you got multiple threads running, we have to put pauses everywhere because we're getting ready to go through the whole thing. So everybody out of the house.
Yep.
While we figure out. And both the JVM and the CLR have actually been very much at a lot of the forefront of garbage collector technology, where they've said, you know what, we can actually do a stop the world collector, but as long as you're not doing anything that involves the memory system, we don't actually have to stop you. Now, of course, the key thing is you have to make sure this is provably correct for all possible kinds of things, which is why, Sun, now Oracle, really experimented with a lot of different collectors. And Microsoft said, we'll experiment, but this is only going to be the one that we ship the CLR for the significant time frame.
Yeah.
Right. So it's a fascinating subject in of itself.
Yep. And since we've gotten one more step onto that, just for folks online or possibly listening to this in the future, there is, if you do mission critical code, namely things that run in control systems for cars, control systems for airplanes, control systems for rockets. It's very, very common to just simply have dynamic memory allocation forbidden. Right? Thou shall not use malloc, new, or anything that uses anything anywhere similar to that. You get to allocate all your memory at the beginning. By usually whatever means you want, depending on your group. And that's it. You do not allocate during your main runtime. Because, this is, and they just solve it that way. So that's another solution to the problem.
Scott Myers was telling me once, we were sitting talking about a bunch of stuff. He was talking about teaching a class somewhere. And of course, he was going through a lot of his effective, C++ items. And of course, if you override operator new, you must override operator delete. One of the guys in the class said, oh, Scott, we don't need to do this. We can move on. Scott's like, no, really. If you override new, you have to override delete. He's like, no, Scott, we really don't need to. It's like, seriously? He's like, no, Scott, we write the guidance control software for the Sidewinder missile. Yeah. If our program runs to completion, the computer is destroyed. And Scott said, you're right, we can skip this one, and moved right along.
Yep, there's always an edge case.
Yeah.
One other interesting thing I've heard about garbage collection is that sometimes you don't have to do it. If you're writing a microservice that just terminates, you may never have to do any garbage collection at all, in which case the managed language can be faster.
Absolutely. Yeah. The JVM specification actually explicitly says a perfectly legal JVM implementation can do no garbage collection whatsoever. And they've recently introduced what they call the zero garbage collector, which essentially just does a no-op every time GC is asked to run. The beautiful thing is it'll allocate great. And if it's a short running program and the heap is large enough, ain't nothing faster in the world.
Right.
Right. And that was one of the reasons why the C# code could sometimes run faster than the C++ code, because C++ would make sure and methodically call the destructors on all of those person objects. But C# says, we're shutting down. I don't need to call any, there are no destructors. All we're doing is freeing memory. So I know how to do that in bulk. And so it all just goes away because the process goes away.
Yeah.
Right.
Yep. I've used that a couple of times.
Yeah. And so that definitely makes things go a heck of a lot faster, particularly during shutdown. But even, obviously you can't run a server that way. But for a lot of your short running desktop apps or command line apps,
Might be able to run a microservice that way if the microservice gets started up every time.
if you're doing it solely in a Lambda and they're not keeping it around, which a lot of the Lambda type stuff wants to do now because the startup costs for some of these managed languages is so great, they'll want to try to recycle those processes, which obviously is not going to work if we're not running with any kind of garbage collector. But, to your point earlier, Lloyd, context matters, right? It depends is the consultant's favorite answer.
Yep. Okay, any other thoughts, comments? We got about 15 minutes left. I know if we get out of here a little early, our host is going to be very happy with us because she's been here a long time, so.
But she's going to have to wait for the maximum of all the group going on right now to get done.
That's true. But at least it won't be us, which sometimes it is. Okay, thanks, folks. And yep, good to see folks. We'll catch you folks next month. All righty.
You can actually stop the recording from here?
Yes, they've actually given me control